Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. Identity and access management doesn't exist in a vacuum. In today's enterprise environments, systems are constantly talking to each other across platforms, across domains, and across vendors. If those systems can't understand one another, or if the trust relationships between them break down, security and usability both suffer. That's why interoperability and attestation are critical. In this episode, we explore how identity systems integrate across diverse technologies, and how attestation ensures that identity and access controls remain reliable, trustworthy, and auditable. Let's begin with interoperability. In the context of cybersecurity and identity management, interoperability means the ability of different systems, platforms, and services to work together effectively, especially when they use different vendors, architectures, or identity protocols. For example, you might need your cloud-based single sign-on solution to integrate with an on-premises directory, or you might need your internal identity provider to federate with an external partner's authentication system. Without interoperability, users face login friction, admins face management headaches, and organizations increase their risk of misconfiguration or exposure. To ensure interoperability, systems need to agree on a few things: how identity is represented, how trust is established, and how authentication and authorization are communicated. That's where standards come into play. Protocols like Security Assertion Markup Language, OpenID Connect, Lightweight Directory Access Protocol, and OAuth all provide ways to express identity in a consistent, machine-readable format. But even when everyone is using the same protocol, implementation details can vary. That's where the challenges begin. Let's walk through a real-world example. A global nonprofit organization adopts a cloud-based collaboration suite for its teams around the world. The internal identity system is built on Microsoft Active Directory, while the new cloud service supports SAML-based federation. During the initial setup, the IT team configures a trust relationship between the two, but users in some regions report failed logins and missing profile attributes. After investigation, the team discovers that the Active Directory does not populate all the required claims expected by the cloud provider. By adjusting attribute mappings and updating metadata, they resolve the issue and achieve full interoperability. The lesson? Even when standards are followed, configuration details must be aligned. Another example comes from a university that uses multiple learning platforms, each with its own authentication system. To simplify access, the university implements a centralized identity provider using OpenID Connect. Some platforms support the protocol natively, while others require custom connectors or API integrations. Ensuring consistent session handling, logout behavior, and attribute mapping across all platforms is key to maintaining secure, seamless access. Best practices for ensuring interoperability include using open standards wherever possible, working closely with vendors to understand integration requirements, and documenting identity flows in detail. Testing across all edge cases like password resets, token expirations, and user role changes is critical to catching issues before users encounter them. Security must also be maintained during integration. Just because two systems can connect doesn't mean they should. Trust relationships should be established carefully, using signed assertions, secure transport, and clearly defined scopes of access. Expired tokens, revoked credentials, or expired metadata can all break interoperability and potentially expose systems to unauthorized access. Now let's turn to identity attestation. While interoperability ensures that systems work together, attestation ensures that identity and access controls are properly validated. In simple terms, attestation means proving that the identity of a user or the security of a device has been verified and can be trusted. There are different types of attestation. The most common is user identity attestation. This occurs when a system confirms that a user's identity has been verified, either during onboarding, through a trusted identity provider, or via multi-factor authentication. This type of attestation is often included in security assertions or access tokens that accompany single sign-on requests. Let's take an example. An employee logs into a corporate identity portal using multi-factor authentication. After successful login, the identity provider issues a token to a cloud storage service. That token includes an attestation that the user's identity was verified using multi-factor methods and that the account is in good standing. The cloud service accepts the token and grants access based on trust in the attestation. Another form of attestation involves devices. In this case, device attestation verifies that a system or endpoint meets specific security standards before it's allowed to connect. This might include confirming that the device has an up-to-date operating system, active antivirus, full disk encryption, or a secure boot configuration. Device attestation is commonly used in network access control systems and in zero-trust architecture. Let's look at another real-world example. A healthcare organization uses a secure virtual desktop infrastructure for remote access. Before a device is allowed to connect, the system performs attestation, checking the security posture of the user's endpoint. If the device passes the health check, access is granted. If it fails, due to outdated software or disabled antivirus, access is denied or routed through a restricted virtual local area network. This ensures that only secure, trusted devices can interact with patient data. Attestation can also be applied in compliance and auditing contexts. During an internal review or external audit, organizations must demonstrate that their identity systems are properly configured, that authentication policies are enforced, and that only authorized users have access to sensitive resources. This means maintaining logs, generating reports, and validating that users are being proofed and monitored as expected. For example, a financial institution undergoing a payment card industry data security standard audit must attest that all users with access to cardholder data have unique IDs, that authentication logs are retained, and that multi-factor authentication is in place. Failure to provide this attestation can result in fines, penalties, or reputational damage. Attestation becomes even more important in federated environments. If your identity provider is asserting that a user has been authenticated, the relying party needs assurance that the authentication method meets required standards. This is often expressed through metadata, trust frameworks, or federated agreements that define acceptable methods and minimum assurance levels. To ensure effective attestation, organizations must implement clear identity proofing policies, use secure protocols for identity assertions, and maintain logs that show when and how users were authenticated. They must also audit these processes regularly to ensure they are working as expected and adjust them as risk or regulations evolve. To summarize, interoperability and attestation are two sides of the same identity security coin. Interoperability ensures that systems can exchange identity information securely and consistently, while attestation provides the trust that users and devices are who they claim to be. Together, these practices allow organizations to build scalable, secure, and efficient identity infrastructures that support single sign-on, zero trust, and compliance requirements. For the Security Plus exam, expect questions about integrating identity systems using open protocols, resolving interoperability issues, and validating trust relationships. You may also see scenarios where attestation is required for network access or cloud authentication. Review terms like identity provider, trust framework, metadata, token assertion, multi-factor verification, and posture check. They are critical to understanding how identity systems function in real environments. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.